Over the years on my channel, I've tested many portable power stations all the way up to 3600 watts, but I've never tested one like you see right here. This is the first one that I've seen that would be considered a compact survival portable power station because it is in this briefcase handbag design, making it very easy to transport, and it also has a built-in folding solar panel for charging. This power station is made by Browey, and the model is DS-S1600. This unit was sent to me by the manufacturer, but that does not mean you won't get an unbiased review. If there's anything about it I do not like, you are going to hear about it. Okay, to get started, let's take a close look at the entire power station, and then I'm going to show you what's included, and then we're going to move on to some testing. Looking at the end of the power station, you have this liquid crystal display, which is turned on with this display button. Push it once, you can see the battery state of charge, 80%, and right over here, you can see this display with all the segments filled in and what each one means. There is a 15-second timeout on that LCD. Over here, you can see you have USB Type-C, power delivery up to 100 watts, and over here you have Type-A ports up to 18 watts. Over here you have two DC output jacks. These are DC 5525, and you also have an input right here. That's what you're going to use to charge the power station using AC mains, your car, or even an extra solar panel that you want to plug in. To turn on the DC output, push DC. That's going to be your output wattage, and right now DC is on. You also have a DC accessory socket like you would have in your vehicle, 12 volt. Up to 10 amps. We're going to be checking that out. And then down here at the bottom, you have AC. Now you can see here, 120 volt output, 60 hertz sine wave. Supposedly, we're going to take a look at that. You have two outputs. Some manufacturers like to put the receptacles this way. I prefer them the other way, but it does not affect the operation. Now let's take a look at the rest of the power station. On the top edges, all four corners, you have these rubber inserts, like bumpers. On the rear side, you have this very nice tilt-out stand. That's going to allow you to adjust the angle of the power station when the solar panels are extended. So you can have this power station, the solar panels, pointed directly at the sun, perpendicular. Over here on this end, you just have your internal cooling fan, ventilation openings. And this is the side with the solar panel. So to open this, very simple. Lift up. Quality appears to be very good, and this is a 40-watt panel. Keep in mind, you're not going to rapidly charge this power station using the solar panel. It's more, like I said earlier, survival purpose. So in the event you're stranded or your vehicle breaks down and you cannot charge this power station, you will always be able to charge it back up slowly. Also included is a well-written owner's manual. Also this padded case. Let me unzip it and show you what's included. AC mains power cord. It's going to plug into the charging brick. Here is the charging brick. 24 volt, 10 amps. Plugs into the input port I showed you at the front of the unit. Power cord for charging in your vehicle while the engine is running. You also get, which is very nice, this short DC jack extension cord along with all these different adapters. So you have many different jack styles that can be used with this power station. This power station has a 48-month warranty, which is very good. The Browey S1600 model has a built-in lithium iron phosphate battery pack, cycle life 3,500 times, and after that point you can expect about 80% capacity. Weight of the power station is 12 kilograms or 26.5 pounds. The dimensions of the power station are 5.7 inches wide or 14.5 centimeters, 13.3 inches or 33.9 centimeters, and 17.2 inches front to back or 43.6 centimeters. This portable power station is approved for multiple certifications, including UL. The AC output power is 120 volts, 13.3 amps, 1600 watts, pure sine wave output with surge capability up to 3200 watts. When this power station has been fully drained, you can expect about 5 hours time using the wall charger. Vehicle can take 6 to 12, depending on the input voltage, 12 to 24 volts. Solar is going to take a while, like I said earlier. It could take 3 days, 8-hour days. But in the event this power station becomes fully depleted and you have no way to charge it, you're definitely going to love that fold-out solar panel, because if you let it sit in the sun for about an hour, you'll be able to power what you need. It could be a satellite phone or other electronics. This Browey portable power station has multiple built-in protections for the battery pack and power output. Charging temperature for this power station is minus 10 C to 45 C or 14 degrees Fahrenheit to 113, and the discharge temp is minus 20 C to 75 C or minus 4 Fahrenheit to 167 Fahrenheit. Now, to get started with the testing, I'm going to start with the DC side first. So I want to take a look at the maximum output for the Type A ports, and then I want to take a look at the Type C. Now, the 12 volt output, this accessory socket is tied together with these two. So I don't have to check each one. I just have to plug into the socket here, place a load on it to see how well it performs. So let's get started with the Type A port first. Okay, so I'm going to take the tester, plug this in, turn on the DC output. Over here is the wattage display. So up to 18 watts it should handle. I'm going to set this at 3 amps. I'll show you in a minute that it's set at 3 amps. I'm going to turn this on. At 3 amps you have almost 16 watts according to this, 5.3 volts, and back to 3 amps. Let's increase now to, you see it went to 16 over here. .25 is at 17, and we're showing right here 17.2. Keep increasing. Okay, so 17.4 watts on one of those ports was no problem. Now let me see if this 18 is for both, combined, or for each one. So let me put this over here. It's on 3.27 amps. Turn it back on. Back to 17. Now I'm going to take my phone and also plug that in. And let's see what's going on here. So the fact that this did not go into overload indicates that it's up to 18 watts per USB Type A port. So I did confirm that it's only up to 17.4 watts. So you have up to 35 watts that you can use on the Type A ports. Now onto USB Type C. This is a power delivery port. It says it can handle up to 100 watts, and it's a input and output USB-C, so it's bi-directional. So it can put power out, and you can also charge, which is really good, charge this power station through the USB port. So let's put this in, turn this on. Let's go to channel 2. It's set for almost 20 volts. Here it goes, changing. Let's go all the way back to 20. Now I'm going to put let's put this down to 3.5 amps. Over here you'll see the wattage. Let's turn on channel 2. 68.25. You're going to have a voltage drop on this wire, and that's the reason why it's showing higher here. So I'm going to increase the current on this side with the load and bring this up to right around 100. So definitely no issue supplying up to 100 watts using the USB Type-C port. I'm going to let this sit for a few minutes just to make sure there's no issues, and I'll be right back. No issues with this, so let me turn this off. Now I want to plug in an external source of power directly into the USB Type-C port to see if it starts charging the power station. Right here we have an external source for USB Type-C, only up to 60 watts with this other power station. So I'm going to plug it in to see if we actually charge. Yes. And it is charging. That is fantastic. I haven't seen any power stations yet that can be charged using USB Type-C. The battery in here is a higher voltage, so clearly there is a DC to DC boost circuit inside to get that voltage high enough to charge the internal lithium iron phosphate battery pack. So 66, you know you're good up to 100, and that's really a great feature because you can also use, in conjunction with the folding solar panel here, an additional 60 watt folding solar panel, so you'll have 100 watts charging this power station, and it'll charge way faster than the built-in panel. Like before, you're going to see a little bit of a voltage drop across this wire. The wattage is going to show higher here and lower here. So I'm just going to keep increasing until the wattage is around 120 or just under. So let's switch to channel 2. Plug this in, see what the voltage is. This is an accurate reading, 11.975. So it appears to be a regulated output at 12 volts. It's not a, which is fine. It's not going to be 13.8 like your vehicle's engine is running, but it is very close to 12 volts. You're going to see that voltage drop only because of the wire. So let's take a look. Let's turn it on. So 11.3. So there's a 0.7 voltage drop. 120 there. And we're close to 9.6 amps. I'm going to leave this running for at least 15 minutes just to make sure there's no issue. All right, so 118, 119, around 9 watt difference across this wire. More than likely the connection in the socket, that's what generates a little bit of heat. Yeah, I can feel it a little bit there. And the wire is only slightly warm. So I don't see any reason why this output could not supply up to 120 watts to a 12 volt load. Okay, now let's go on to the AC output testing. First, let me take a look at the output voltage. I'm going to hold this over here. Hopefully you can see it clearly. $122.3. Now we're connected to the oscilloscope to take a look at the waveform. Hopefully it's a very nice sine wave. And over here it's going to show the frequency to make sure it is definitely 60 hertz. Okay. Nice waveform. And you can see over here 60.0000 hertz. So 60 hertz, definitely 60 hertz. 120 is coming up 122.4, which is good. And the waveform looks great. Now the next thing I want to do, just like my other testing videos for power stations, I'm going to place an inductive and resistive load, which is high wattage, a hairdryer, just to see how this waveform looks under load. Everything looks good. Now we're going to take a look at what the expected charging wattage is going to be when you plug this into your vehicle with the engine running. The alternator should be running and you can expect around 14 volts going into the power station. So I'm going to set 14 volts on the portable power supply, and we're going to see what the wattage is. You can expect just under 10 amps flowing into the power station. You can see 137 watts. We're 123. Like I said before, with these connections here, especially the way it is on this accessory plug, you're going to show lower. So expect between 128 and 135 using your vehicle with the engine running. Now let's take a look at the expected wattage using the charging brick. You can see the fan is now running. Pretty quiet. 233 watts is what you can expect when using AC mains to charge this power station. I'm going to charge this up to 100%, and then we're going to take this outside and move on to the AC output testing. 1/2-inch hammer drill first. As you just saw, 350 to 400 watts. Under load, it's going to be probably double that, so not a problem for the hammer drill. Now a mini skill saw. So no problem starting it up, and I noticed both of these inductive loads instantly started. Does not appear to have a soft start, it just powers it right up. 350 to 400 watts for this mini saw, and under load slightly higher, it doesn't go up much. Now we're going to try this rigid shop vac. Let's see how well this does. I saw a peak of 1,488 watts when it started up, and then while it was running, 1188. Now this is the circular saw that you've seen me use to test all the power stations for a high level of inrush current. So if this power station can actually start this, then it's really good because it should be able to run just about anything. So let's give it a try. All right. Reset. So this is way too much for this power station, as I expected. The good thing is we know the overload protection works. Now a resistive load which is higher than the rating of this power station. Let's see if it starts it up. If it does, how long can it run? That was 1,718, and it ran for, like you saw, maybe 5 seconds and shut off. So if you had to start something momentarily at that wattage, it can do it. Okay, now we're going to check out this refrigerator. See, it's off. It's plugged in. Let's put this on. Let's turn this on. Okay, I had to wait a while, and it finally turned on. It went up to about 650 on the startup, and now it's running fine. 109 watts. These new refrigerators don't draw a lot of current in order to cool. Okay, the portable power station is now connected up to my wall-mounted microwave oven. Now, this is a high wattage oven. More than likely, it's not going to be able to do it. It's going to exceed the 1,600 watt maximum for this power station, but we're going to try it, see if it starts up easily. Water. Let's do 30 seconds. Oh, it was running good until it hit 1,860 watts. So knowing these results, I can tell you that a countertop version more than likely would run. The majority of your portable power tools and appliances like you see here, hair dryer, toaster oven, not going to be a problem at all. All of these together is going to put us just a hair under 1500 watts. This is made constant power output up to 1600, so I'm going to keep it just a little below. Hopefully it does not turn off. And then we're going to see how long it takes to fully drain the battery in this power station using this load. Right here's the time. I'm going to start it once I power everything up. $1,480. Starting to drop off the voltage at the output once we got to about 95% depleted. Before that it held. Dropping off. And now we're flashing. It's almost fully discharged. Okay, just turned off. So this turned off right around at 110 volts. So 95%, almost the full duration of the discharge cycle, was stable. You can see it was 1460 all the way down until we got to around 32 minutes. Stop that. And then the voltage started to drop. I think it cut off at 110. So based on the testing I just did, 1500 to 1600 watts continuous output should not be any issue for this power station. And if you wanted to go above that level, like I did with the hair dryer to 1720, you could use it for a short burst. In that case, it was about 4 or 5 seconds. All right, let's take this inside right now, see if it charges immediately after finishing this test. Once we check that, I'm going to take this outside. I'm going to put it in the sun to see how well the solar panel works. The test was only completed 5 minutes ago, and it's charging up. That's a great thing. You don't have to wait, and I also noticed the power station is only warm. The Browey power station now has the solar panel opened up, and the power station has been positioned perpendicular to the sun. Today is a very clear day, and as you can see, the input wattage is 40. And that is it for the testing of this power station. I can say it performed extremely well, and I definitely like it. I hope you enjoyed this video. If you did, be sure to rate, thumbs up, and share. Thanks for watching.